Hi, in this session we are going to learn how do we sort the elements. Now when you talk about sorting of the elements, it is basically arranging the elements in order, right. So when you want to arrange the element, remember we can arrange in ascending order or in descending order. And when I talk about arranging, it is not only for numeric values, you can also do it for strings or any other data type, right. And in order to sort, we have various algorithms. We do have bubble sort, selection sort, insertion sort, quick sort, merge sort, right. So we have various algorithms. Okay. Among them, the most basic and the easiest algorithm is called as the bubble sort. We will try to learn about the bubble sort. Now let us take up a set of elements and let us see what is the logic behind bubble sort, right. Now you can take up any element, like for example, let us say we do have some elements like this. Okay, we do have 5 elements. What the bubble sort does is, it basically takes the first 2 elements and compares. So the first 12 and 56 is taken and they are compared. Now if you want in ascending order, it checks if the first element is lesser when compared to the second element. If that is true, it means it is already in order. So we do not need to do anything. Okay. So we can proceed further, but if it is not in order, we interchange the elements, right. But if you can just observe, 12 is lesser when compared to 56, no problems. So 12 should be before 56, okay, that is fine. Now we take up the second element and the third element, we compare this. Now when you compare this, 56 is not lesser when compared to 32. So 32 should come before 56, right. In order to bring 32 before 56, what you do is we interchange the elements. Remember, first time the first element was not touched at all, second and third element are interchanged, right. So 32 comes here, 56 comes here. Okay. Now your third element is 56 and the fourth element is 89. We compare this 56 with 89, clear. We compare this element with this element, third element with the fourth element, right. Now they are in order, so we do not do anything with 56. Then we compare the fourth element with the fifth element, 89 with 45. Now when you compare this 89 with 45, since they are not in order, what happens is we interchange that. When you interchange, 45 comes here, 89 comes here. Now the question is easily sorted. The answer is no, because 45 is after 56, right, it is not sorted. But you can observe one thing, the smaller elements start moving upward and the largest element is pushed to the bottom, right. Now this running through the list once is called as one pass, right. This way we need to do several passes, we have to repeat the same operation on the entire list, right. Like again we have to compare 12 with 32, okay. Then what happens is there will not be any swapping in this, 32 and 56 there will not be any swapping, 56 and 45 you can just see 45 will be coming here, 56 will be here, and as usual. Now we can just see that the list is arranged, right. Okay. Now we will try to write the program wherein we compare 2 consecutive elements, and then if they are in order we do not do anything, if they are not in order we interchange the elements, right. Okay, we will just do it once, like we will only take up these elements and then reach to this particular point, right. After that we will try to understand how many times do we need to repeat this, like going through the array again and again, how many passes do we require it. Okay, we will try to understand that, but before that we will try to do the program of running through the array once, we call it as one pass, fine. So now the input array, I will take up the same information. Here I have the code to read the elements from the user, but instead of reading the element from the user, I will just try to initialize the array, and once we work this with proper data and we understand how things are working, then later on we can always take up data, any data which is coming from the user at the runtime, and then we can sort the data. For the time being, I will just try to create an array, right, and I will place these elements, and I will not be reading the value of n also, because the n value is, we know that here it is 5, right. So, I will not be reading this, but remember once we understand this concept, then we will try to learn how do we read values from the user, and then sort on that particular data. Random data we will try to take it up later, fine. Okay. Now, I will just return it here, right. Now, what I said is I need to compare the first with second, then if they are not in order, interchange. Then I should again compare second with third, third with fourth, fourth with fifth, right. I need to know how many comparisons do I need to perform totally. If you take up this is one comparison, this is second comparison, this is third comparison, this is fourth comparison. How many elements I had here? 5 elements. How many comparisons? 4, right. So, the number of comparisons required is the number of elements minus 1. So, I will be running a loop wherein it basically goes all the way up to n minus 1 number of times, right. Okay. Now, I am starting with 0, right, the index 0. So, when I use a of I will get the first element, then same way I plus 1 will give me the second element. So, I need to compare, is it in order or not. If it is not in order, I need to swap, right. So, I will just compare if array of I, if it is not in order, remember not in order since the first element is greater when compared to second element. If it is greater when compared to the next element, the adjacent element, if it is not in order, we need to swap. Now, if you want to swap, you can always swap using a temporary variable or without using a temporary variable, and I prefer using a temporary variable, right. You can always try this out, same thing without using a temporary variable, it will still work, fine. Okay. Now, remember we are running through the array only once, we are not repeating it again and again. I want to see what is the result after this operation. So, the number of times the loop repeats out here is like n times, this is to print the elements, and here I would like to print the elements, right. I would like to print the element here. Okay. Right. Okay. Now, let us try to run this program, and the output what is generated by our program and whatever we have studied, let us try to compare this and just match up that is it working like it's the same way what we studied 12, 32, 56, 45 and 89. Clear? So, we only went through this array only once, and this is the result what you got, and we wrote the program and we have understood. Is this clear? Right. Okay. The reason why I am going to use step by step is like, see, you should not by heart the programs, right. You should learn how do we solve the problems, right. Okay, when you identify the smallest subset, try to solve that and then try to build from, okay, we call it as bottom up approach kind of thing. Clear? Okay. Now, this operation I need to do it again and again, but the question is how many times? Okay, right. In the data whatever we have taken, we did it twice and it is arranged, but is 2 times sufficient, right? Or should we do 3 times, or should we do 4 times, right? So, for that I will take up one of the other data set. Then I would say you should always take up various data sets, different order, try it out, and then you yourself can understand how many times we should repeat. Fine. Now, let me take up some element, let us say right. This is the data what I am taking. So, I have this 89, 67, 5, 23, 12, right. Okay, it could be okay. I will just take it up this, yeah, okay, right. This is the data what I have taken, And if you can just observe this particular data, this data is completely in reverse order, that is in descending order, fine, okay. But I want to sort this in ascending order. I want to know how many times I need to run through the array, right. So, I compare 89 with 67, then what happens is there will be a swap here because 89 is greater. So, 67 comes here, then 89 comes here. Then you compare the second element with the third element, which is 89 and 35. Again there will be a swap here, 35 comes here and 89 comes here. Now, third element, which is 89 with 23, right. Now, 23 comes here, 89 comes here. Then 89 with 12, 12 comes here, 89 comes here, right. So, whatever I said in the previous case, the largest element is moved to the bottom. Remember, here the largest element was at first, but here it was somewhere just the second last element. No matter wherever is the largest element, after one pass you can assure that that will actually move to the bottom, right. Now, I need to repeat it once more, right, because it is not fully sorted. So, I need to take up 67, is it less 7 compared to 25? No, 35 comes here, 67 comes here. Then I will compare 67 to 23, then 23 comes here, 67 comes here. 67 with 12, 12 comes here, 67 comes here, 67 with 89, right. Right. Now, you can observe the last two elements are in order, right. Again I am telling you, take up the data sets of your own, any random data sets, you can verify after one pass. What is guaranteed is the largest element moves to the bottom. After the second pass, the last two elements will be added proper places, that is assured, right. Okay. Now, after that what I will try to do it is, again I need to do this. So, 23 comes here, 35 comes here, then 35 with 12 and 12 comes here and 35 comes here, okay. And since we already know the last two elements are arranged, so even if you do not compare the 35 with 67, 67 with 89, it is perfectly okay. But if you end up comparing, that is also okay, no problem, because there will not be any swapping, right. So, we will try to do that programmatically also, right. Is it really comparison is required or not required, okay. How do we stop, okay, out here itself, why, how not to perform the last two comparisons here, right, clear, okay. Now, the list is still not sorted. So, now 23 with 12, 12 will sort, okay, comes here, 23 comes here, 35 comes here, 67 comes here, then 89 comes here. Is the list arranged? Yes, it is arranged. How many times did we go through? 4 times, right. And we have studied after one pass the last element is at proper place, after the second last two elements up at proper place, after the third pass last 3 elements are at the proper place, after the fourth pass last 4 elements are at the proper place, right. So, this way now if I say that these 4 elements are at proper place, obviously this should be at the lowest, this should be at the front, okay, front. Now, based on this what we can understand is you need to run how many times? N minus 1 number of times, clear, okay. Now, we already have the code to run through the array once, right. You can need to just repeat this multiple times. What do you do? You can just use a loop, right, okay, and we will try to place this. You want to print after every iteration, like let us after every pass, then you can place this information inside the loop, okay. And whenever you bring in extra loop, please make sure that you try to do the sorting properly, right. Let us try to do the indentation properly out here and done, right. So, here you have to use any other variable name other than I here, right. It can be any variable name. I would like to write it as pass, right, or just P, then that should repeat totally n minus 1 number of times. Right, and I am trying to print after every pass. I am trying to print after every pass, and I like to also print a new line after this. You want to print that after first pass, after the second pass, right? You can just write after percentage d pass, right. Since I am starting with 0 for pass, I can just write pass plus 1, and remember you can also start the pass with 1 and then okay just say pass less than n, because pass is nowhere used here, right. We just need to run through the array. So, if you want you can start this pass with 1 and wherein I need not use this plus 1 here, but in that case it should be like less than n, not less than n minus 1, fine. So, let us try to quickly run this particular code, right, and try to understand. Let us try to take up the same data whatever I had, okay, this is data what I already taken up, you can just see out here 12, 32, okay, this was after the first pass, after second pass this is the data what we had, after third and fourth pass there was no changes, but let me change the data here, let me change this data here, right. So, I would like to change the data wherein you want to hard code it, you can hard code it. Or you can, if you want, you can also read it from the user at the runtime, right. Okay. Compare this with whatever we studied theoretically. Just check out after the first pass, did we get 67, 35, 23, 12 and 89, then 35, 23, right, 12, 67, 89, right. Is this clear? Okay. Now, since we have already verified with hard coded values, now you can always take up any values from the user at the runtime, wherein the value of n can be anything whatever the user wishes, right. Okay. And I do not require the statements, you can run through this and play around with this, right. Okay. If you are not interested in looking at after every pass, what you can do is you can just take this out and put it outside this loop, then it is going to print only once the final sorted list. Is this clear? So, the final sorted list will be the same, you can just observe I have copy pasted this and this is like final sorted list. Right. Okay. See, this is in your hands, either you want it after every pass or you do not want it after every pass. You can take up any number of elements. I want to say I would like to work with 8 elements, I would like to work with some values, right, 1, 2, 3, 4, 5, 6, 7 and then let us say, right. We can also have duplicates, no problems, it is not that every element should be unique, right. I have entered 7 elements, so I will just enter one more element, right, and you can just observe, right, 7 was duplicated, 23 was duplicated, no problems, or you want to try out completely unsorted one. Clear? Okay. I would say please do verify with various data, but please do make sure that you write down first, because understanding is something which is important, and then use this code to verify it, and if you are only interested in printing the final result, this particular code can be deleted, fine, right. Thank you.